right, folks. Hello, welcome. Thanks for joining this session from 3 Pillars to More with OpenTelemetry. Super excited to be joining you here today. Love being out in India for KubeCon. 30 slides in 30 minutes. This is going to be a lot of fun. So let's see how it goes. I'm going to jump right in. You probably can infer from this slide, but I'm talking about 3 pillars. I'm talking about the 3 pillars of observability. Those are primarily traces, metrics, and logs. But there's actually a lot more than those telemetry signals when it comes to OpenTelemetry and when it comes to observability in general. First, a question. How many people are using OpenTelemetry in production today? Show of hands. Okay. All right. Next question. How many people are not using OpenTelemetry at all today? Hands. Hands? All right. Perfect. How many people do not know really what OpenTelemetry is? It's okay. All right, good, great. We're going to do some introductory stuff. We're going to drill into the 3 pillars, and then we're going to talk about the future. That's kind of the goal for the session for today. First, a quick introduction. My name is Steve Flanders. I'm a Senior Director of Engineering at a company called Splunk, which was recently acquired by Cisco Systems. I have been involved with the OpenTelemetry project since the very beginning, and the precursor project, which was called OpenCensus. OpenCensus and OpenTracing merged to form the OpenTelemetry project. I've been working in the observability space for well over a decade. I built logging, tracing, and metric backends or observability platforms. I currently work at a vendor that kind of does that today. And I authored a book called Mastering OpenTelemetry and Observability. I actually have some copies with me, so there'll be an opportunity to kind of get some of those at the end as well. All right, so let's do a quick introduction first, especially those that may not be 100% familiar with OpenTelemetry. So what is it? Basically, it's an observability framework and an open standard that you can use to instrument and collect data in your environment. Specifically, this is telemetry data, traces, metrics, and logs being the most common, but they are not the only things. This open specification is really the foundation of everything within OpenTelemetry and what makes it compatible with a variety of different formats that are out there today. It's also what allows the project to be vendor agnostic. If you follow this open standard, then it shouldn't matter which backend you're sending the data to. As long as it supports OpenTelemetry, you should be able to move between different backends however you see fit. Now, that specification is foundational, but on top of it, there are basically 2 reference implementations. There are instrumentation libraries. This is what goes in your code in order to generate or instrument the traces, metrics, logs, or other signals that you care about. And then there's a data collection aspect. Think of it like an agent or like a gateway or an aggregator or something to that effect. It is used to receive, process, and export this telemetry data at the end of the day. Those are the 2 primary components that you'll see. We're going to drill into this a little bit more in just a second. Now, why does OpenTelemetry matter? I kind of mentioned it's an open standard and it's vendor agnostic. That's a huge value proposition for end users because at the end of the day, you don't want to use a vendor solution, spend all this investment in it, and then if you want to change, you have to rip it out and install something else. That's very impactful. There's not a lot of value to that. And some of these signals, like traces, for example, they have to be instrumented end to end in order to actually see things and be able to troubleshoot. So ripping it out is very costly because you're going to lose observability in your systems for a period of time. Beyond this, you kind of get data control and portability. Now you have one standard and one way to actually instrument and collect data in your environment. You control what you send and where you send it to. If you want to send it to multiple destinations, that's fine. If you want to remove information before you send it, that's fine. If you want to add information before you send it, that's fine. OpenTelemetry is actually the 2nd most active project in the entire CNCF behind Kubernetes. So Kubernetes is number 1, OpenTelemetry is number 2. I think that speaks to the fact that this is a real problem in the industry that needs to be solved. And then finally, you're going to see, and I'll show it a little bit more, like a lot of end users have adopted this in production, and pretty much every major vendor or cloud provider supports OpenTelemetry today. Again, I think speaking to the fact that this is important at the end of the day. All right, so let's talk about the here and now today, and then I'll talk a little bit about the roadmap as well. First, to set some context, you're going to see slides that look roughly like this. Basically, I'm going to talk about a specific component in OpenTelemetry. If it says status, I'm going to tell you the status according to OpenTelemetry. Those statuses are basically the 5 that you see listed on this slide. Design, which is it's in development from a specification perspective. Development, which means the code is being worked on, but it's not GA yet. Stable, which is OTel's word for GA, generally available, and then deprecated, which means it's stable, but it's going to go away, so you should be migrating off of it. The final one is mixed. Mixed means that you have stable parts and you have development parts. And you need to be careful there because the development parts could have breaking changes at the end of the day. So I just want to kind of set the context. To be fair, in OTel, there's actually a bunch of other things that you might see, like alpha, beta, RC. They're not really official, but some of the repositories will use them. But like alpha, beta, and RC are all development at the end of the day. What development means is a breaking change could be introduced. What stable means is it will have backwards compatibility between all major versions. So you need to kind of understand the status of the project at the end of the day too. All right, so we'll start with the specification because I said we start with the 3 pillars of observability. So in OpenTelemetry, those pillars or those telemetry things are called signals. That's the name of it. And so traces, metrics, and logs, 3 pillars of observability. Within the specification, it's actually broken down into 3 different components: the API, the SDK, and then the protocol, or kind of the data formats. What you will see is that for the 3 pillars of observability today, OpenTelemetry is stable. Again, stable means GA, so it's ready for use. Now, the ones that say mixed, that's because they have the base functionality today, but some new capabilities are being added. Those are the bullets that you see kind of on the right-hand side of the table. So those new capabilities, they're still in development, and they could have breaking changes, but the other capabilities are completely stable, and you don't have to worry about that part. Okay, but there's actually 2 more signals today in OpenTelemetry. One is called baggage. This is kind of unique to OTel. I mean, it's used in tracing very commonly, but OTel has actually promoted it as kind of a first-class thing that you need to worry about. Baggage is a way of ensuring context and correlation is passed between all of the telemetry data that you have, traces, metrics, and logs. And then finally, the newest thing that OTel has introduced is this notion of profiling. So beyond the 3 pillars of observability, you may, for example, want to get performance information about your code. Profiling is like the next level of granularity within your app. We'll be talking about that in just a second. So I mentioned that there's the specification, which is foundational, and then there's 2 implementations of this. One is instrumentation libraries. So for instrumentation libraries, you need to support a variety of different languages. Here are the major languages that are supported by OpenTelemetry today from an application perspective. There are, of course, community-supported ones as well that I'm not listing here. They're outside of the project, but they may adhere to OTel specification. And when these were built, a couple interesting things happened. So OTel's approach is, for every language, there will be a single instrumentation library for all the signals. So there isn't one for metrics and one for tracing and one for logging. There's one for all 3. So that's kind of unique. A lot of other vendors or companies would actually do this per signal. You can turn on or off whatever you care about. So just because you're using one instrumentation library doesn't mean you have to collect traces, metrics, and logs. OTel is about giving you flexibility and choice every step of the way. And it's also important to note that OTel prioritized these signals in a certain order. Traces were prioritized first, then metrics, then logs, now profiles. And that's going to matter because I'm going to talk about the stability here in just a second. Now, for those instrumentation libraries, you will also have wrappers. So for example, in a serverless environment, let's say for cloud providers, you'll want to wrap those instrumentation libraries. That's provided by OTel as well. And then beyond application instrumentation, you'll also have things like real user monitoring or digital experience monitoring. This is typically your web browser or mobile devices, Android, iOS. There's also RUM instrumentation today available in OTel. And we'll be talking more about this in a minute. All right, so let's start with the application instrumentation libraries. Again, here's a status slide for you. So I've broken it down by the major languages that you saw on the previous slide, and I've broken it down by the 3 pillars of observability: traces, metrics, and logs. As I mentioned, traces were the #1 priority. Well, look at that, it's fully stable, not surprising. Metrics were the 2nd priority. Look, it's almost entirely done except for Erlang and Ruby. And then logs is kind of the most recent one that was implemented. There's still a few languages where it's underneath development, but I would expect that to be resolved very, very soon, right? And of course, if it's in beta, I mean, it's pretty stable. There are still some risks to it, but beta means it's well on its way to getting to the stable mark. Now, this is for what's called manual instrumentation. Manual instrumentation is when you make code changes to your application in order to generate this data. You have to actually edit your code, recompile it in many cases, and then redeploy it. So you're adding stuff to it. There's also something called automatic instrumentation, or it's called zero code instrumentation in OTel now. Automatic instrumentation basically injects itself at runtime to create these traces, metrics, and logs. And these are supported across a variety of different languages, but not all of them. And it supports certain signals, again, not all of them. So this is roughly what that table looks like, and this is constantly changing in OTel, so like it'll update over time. It's worth noting that the automatic instrumentation today is all technically in development. It is not stable. The reason is not because the instrumentation is not stable, it actually is, but automatic instrumentation uses something called semantic conventions. These are key value pairs that tell you something about the data, and the semantic convention is actually a common naming of the key. So let me give you some examples. HTTP is a semantic convention, right? http.status_code equals 200. Well, I want that key name to be uniquely identified across any environment that I send the data to. That's an example of a semantic convention. And all of those semantic conventions, except for some of the HTTP ones for 3 languages, are still in development in OpenTelemetry. That will change over time. They will actually become more stable. And when that happens, then you won't have to worry about breaking changes here. So why does this matter? It's because when you send these semantic conventions to your observability backend, if they change, your dashboards and your alerts might need to change because the name has changed. That's why it's so important to actually stabilize these, but no one else really has, right? Like vendors didn't have a standard for this generally, so this is one of the things that OTel has really been focusing on because it will provide more data portability and more vendor agnosticity at the end of the day. All right, let's switch over to the collector real quick. So as I mentioned, this is an agent, it's a binary, it's a service, it's an aggregator, it's an edge processor, whatever you want to call it, but basically it's a single way to receive, process, and export data. So receive and export, I think, is pretty straightforward, ways of collecting the data and sending it out of the collector. Processing is what you want to do with the data once you received it. A great example would be CRUD metadata operations, create, remove, update, delete. Maybe I have some personally identifying information in there and I want to rip it out before I send it to my observability backend. You can do that with a processor. Maybe I want to add some metadata enrichment so I have the ability of doing better problem isolation. I can do that with a processor. So that's what the collector does. You don't have to use the collector. You don't have to use the instrumentation library. You get to choose with OTel which components you want to adopt. But of course, they integrate very nicely together. So in a greenfield environment, you could actually start with OTel and get this whole thing working end to end. The goal is that it would future-proof your environment because it supports a wide range of different observability backends. Now, it's important to note, if you're not familiar with OTel, that OTel does not provide an observability backend. That's where it draws the line. It is worried about the instrumentation data collection parts. Instead, it offers an open standard so you can send the data wherever you want. And so this supports open source backends, it supports vendor backends, it supports cloud provider backends. So again, you have flexibility and choice every step of the way. All right, so the collector has this notion of receivers, processors, exporters that you saw on the previous slide. There's actually 2 different distributions of the collector. There's one called core. This is for the core capabilities that are specific to OpenTelemetry. The other one's called contrib. That's where you'll find like vendor exporters or vendor processors, for example, or things that are not core to OpenTelemetry. Again, you will see stability based on the different signals. So for the core capabilities, most of it's getting to the stable state. For the contrib, everything's underneath active development today. And the reason for that is because the core has the APIs that contrib need to depend on. So until the core distribution is stable, the contrib ones cannot be stable. But a lot of people today are using this in production. So the big question I get when I show a lot of red on slides is OpenTelemetry ready? Yes, it is. So if you didn't take that as a takeaway, you should. There are a large number of adopters running this in production today. There's a link to that at the bottom. All major vendors and cloud providers are leveraging this today, and all major open source players in the space are also adopting it. For example, if you saw the Prometheus 3.0 announcement, they are supporting OTLP natively now, and if you saw the Jaeger 2.0 announcement, both these projects being in the CNCF, of course, they announced that they are leveraging OTLP as well and collector support from the OpenTelemetry project. Okay, so that's the 3 pillars of observability. Let's talk about the roadmap. So first, all that red needs to become green. So that's basically what this slide says in kind of summary, right? Like there's a lot of work from like keeping the lights on, performance scale reliability, getting those semantic conventions stable. That'll be the primary focus of OpenTelemetry for the next couple of years, of course, but new things will be added there as well. For example, there are new semantic conventions for Gen AI, CI/CD, and mainframes that are actively under development. So this is extending the number of environments that can be supported from an OpenTelemetry perspective. And OpenTelemetry today is in the incubation status within the CNCF. They are up for graduation, so maybe as early as KubeCon Europe next year, that'll happen, but hopefully by next year, OpenTelemetry will graduate from a CNCF perspective. I'll talk a little bit about the specification and why it matters. So I talked to you about the semantic conventions, but you still may not be 100% clear why it matters. On the left, let's say that I have some application that's been instrumented with OpenTelemetry, and it's calling some database that does not have instrumentation. Maybe it's a cloud provider database. You can't add instrumentation to it. If you follow these semantic conventions, you can actually infer the health of that database because I will know all the calls that are being made to it. I'll have a common way of representing it, and I will see all that telemetry data. Now, to be fair, that's not maybe 100% of the telemetry data coming from that database, because if non-instrumented applications are calling it, I wouldn't be able to see that. But it's still better than the state today, which is if it's not instrumented, I would see nothing. Now I can see something, which is very powerful. The second is that OTel has this notion of resources. The resources tell you the infrastructure information, or the where is it information. So this helps with problem isolation and allows me to tie application data and infrastructure data together. So basically, I'm showing an example here from AWS on Kubernetes with hosts, but you can replace this with any cloud provider. It doesn't matter if it's containerized or not. Doesn't matter if it's on-prem. All of this can be instrumented and collect data with OpenTelemetry today. And how this is made possible is that the OpenTelemetry collection architecture works at the application layer, at the infrastructure layer, at the collection layer, and it can correlate any signal that it receives, traces, metrics, and logs. Usually just traces have context and correlation, but with OTel you can do this across any signal type. Again, this is part of the value allowing you to kind of stitch this data together. All right, so what's next? First, I mentioned profiling. That's the newest signal that's being introduced into OpenTelemetry. Profiling is being added to OTLP. I haven't talked too much about that yet, but OTLP is actually the data format and protocol that OpenTelemetry uses, and it's what allows OpenTelemetry to be vendor agnostic. Basically, any data that's received, let's say by the collector, is converted into OTLP format, and then when it's exported, it can be converted into another format. So I can receive in like Zipkin format for tracing, I can convert to OTLP, and I can export in Jaeger. This is what allows it to be vendor agnostic at the end of the day. Elastic actually donated their eBPF profiling agent to OpenTelemetry, and that is currently being converted into the profiler agent for the OpenTelemetry project. And the collector now allows you to receive and export this via OTLP. So a lot of good work is happening. Semantic conventions will be defined as well, but this is actively under development. I was hoping to show a demo, but like it's so under development, I couldn't get it to work. So instead, I'll show you a screenshot. But roughly, what this will do is within an application, it gives you this cool flame chart. I know it's a little bit small for people in the back. I apologize for that. But this gives you kind of the breakdown of where you're spending your time from a code perspective. This is very useful, right? So let's say I identify that like this specific Java application is having performance problems. Well, now I can actually drill into that and figure out where it's spending the time and see if I have a code or performance or memory leak or some other issue in my environment. So profiling is a great addition to the OpenTelemetry project. Next, I talked a little bit about digital experience monitoring and real user monitoring. OTel calls this client instrumentation. Again, this would be for mobile browsers, so like Android, iOS, for browsers or mobile devices, my bad. So for browsers, that would be like JavaScript, for example. For mobile devices, that's Android and iOS. This is actively in development in OpenTelemetry. So there are instrumentation libraries, but the notion of real user monitoring or digital experience monitoring is still being defined within the OpenTelemetry project itself. It's worth noting that there are some nuances here. So DEM or RUM has this notion of sessions. Those will be represented as semantic conventions within OpenTelemetry. For mobile devices especially, getting crash analytics is very important. That is another semantic convention that'll be defined. And there's this notion of session replay, seeing what the end user experienced and being able to replay that data. That's another unique thing for client instrumentation.
So how this will be handled within OTel is basically new semantic conventions are being defined. You can see that there's already a session ID information and event information. Device crash is being proposed right now. It hasn't been merged in, but these conventions will be added, and then the instrumentation can take advantage of this so that the observability backend can take advantage of this. That's basically the future for client instrumentation. Another really cool thing is this notion of entities, which is currently under discussion within OpenTelemetry. So I talked a little bit about resource information, right? Like, how do I tie application and infrastructure together to do problem isolation? Resources are not really entities because they can contain a lot of data. In fact, I've listed 3 very big problems with resources that prevent it from being an actual entity. For example, like resource information can contain non-entity attributes. If that's the case, then how am I supposed to know what an entity is versus not? And what is actually required from an entity perspective? Now, you might be wondering, like, why does this matter, right? If I have infrastructure and application, isn't that kind of good enough? I mean, yes, it is, but like, what if I could have my observability backend actually be able to navigate based on the notion of an entity? Let me show you a little bit more. So I'm going to show you a quick example here. Here is a span from Jaeger, and this is the process information. Process information is the equivalent of a resource in OpenTelemetry, and you can see there's a bunch of key value pairs here. I have a container ID, an OS version. I can see some stuff about the telemetry information, right? In the case of like an entity, let's say I have a metric that's coming in, OpenTelemetry will take each of these and add a new dimension to the metric. Well, from a cardinality perspective, that's very expensive. And do I need all of this to identify this object? I don't, right? I definitely don't need the telemetry data at the very least. I probably don't even need the OS stuff because the OS is not unique to my identity. A Java process may not care if it's running on Linux or Windows. So it doesn't really help me. So instead, OTel is investigating, hey, can we have like this notion of a service entity or a process entity? And can we say that like certain attributes are required and others are optional? That is basically the work that is actively underway. And if this is successful, then observability platforms can use this to create navigation flows in their product. And an end user would not have to tag this information themselves. A lot of end users today try to add their own entity information, and they have to come up with some sort of naming standard. OpenTelemetry is looking to normalize this and really make this problem go away. Another cool one is called OTTL. This is specific to the collector, and it's basically a DSL, domain-specific language. So if you're familiar with the collector, it actually uses YAML for configuration. How many people like YAML? Anyone? Oh, okay. How many people don't like YAML? Show me more hands. Oh, it's about 50-50. I don't like YAML. That's the side I'm on. So, so YAML it's powerful, but it's complex, and you need to understand like how to write it, right? So I'm going to give you an example in the collector. This is called the attributes processor. Now, if you look at this, do you understand what it does? I mean, the bottom, the actions, I think are kind of clear. It says add or insert an HTTP status code with a value of 200. But what does this include attributes thing mean? It's a little like confusing, right? So this is where the DSL comes in. The highlighted line is the equivalent of everything on the left. SQL's way easier to read, way easier to understand, right? Like, oh, okay, you only want to add that status code where the attribute has a method that is post. Much clearer, much easier to understand, and one line, not multiple things that have to be indented the right way. Where do I put that hyphen? Like, the syntax is kind of a mess, right? So the collector is moving down this path of defining a domain-specific language to really ease the configuration, and it provides a lot more flexibility. I didn't highlight the transform stuff here, but you can see it does this in specific contexts, like a metric or a trace or a log. That's a lot easier to write than building a whole bunch of different pipelines in the collector. So this is kind of the future for the collector generally. And then one more thing for the collector is this notion of OpAmp, which stands for Open Agent Management Protocol. It actually doesn't stand for OpenTelemetry Agent Management Protocol, fun fact. It's open because this is actually possible to control any agent if they adopt it. So it's not specific to the collector, but of course it works with the OpenTelemetry collector. So the idea here is, hey, I have hundreds or thousands of collectors. I want to configure them in different ways, or I need to upgrade them, or I need to patch them for security vulnerabilities. I need to understand the health of them. Are they scaled properly? Are they having performance issues? Like, what are the metrics and observability footprint for my collectors across my fleet? You can kind of solve that yourself if you're using like Ansible or Chef and you're comfortable with different configuration management tools. Otherwise, you need to do it, you need to figure something out. Well, OpAmp is looking to make this way easier. The idea is an observability backend would be able to control and manage these collectors if you wanted it to. That's extremely powerful. So there's actually 4 components to OpAmp. The protocol is the most important, right? It's kind of the wire format for how you talk back and forth between some sort of backend and the collector or whatever agent that you're using. In the case of the collector itself, there's actually an extension that's been built specifically for OpAmp. Certain things are implemented, certain things are not. I've listed them at a high level. I don't have time to drill into them, unfortunately. There's this notion of a supervisor. So the supervisor runs next to the agent or collector, and it basically supervises and controls it at the end of the day. And then you have a server, basically the back end, and how you'd actually configure this. And you can see that these are in various states, including in development or beta. Now, I'd like to actually demo that one. I'm going to try to do it really quick here, because you can see how powerful and cool this is. So I have OpAmp. It's actually written in Go locally on my system here. And I am just going to start the server real quick. Really hard to do with one hand. Server starts. So now I have an OpAmp server up. And I'm going to come back here. Let's just refresh, because I should have restarted here. So this is the server. It's ugly. It's OK, right? You can style this however you want. There are no agents running right now, right? Very, very simple. Great. So the server's running. Now I'm in the supervisor directory. And I have this supervisor config file. And yes, it's in YAML. It has a server endpoint. So that's how I'm going to connect to it. I'm connecting to it locally. And I have to tell it where my executable is. So where is the OTel collector binary? I have contrib version 113 here, 113 here. So that's all that I need. And then I can just say, go ahead and start the supervisor. And the supervisor will go ahead and start an agent for me. So very, very quickly here, it actually spun up an agent. And I can prove that that worked. Because if I come back to my server, all of a sudden I see an agent. Very cool. So I click on my agent, and you can see it already passed the configuration to it. Here's the lovely YAML configuration for the collector. Isn't it nice? You have your receivers, processors, exporters. It built a pipeline for us. And you can add new configurations. So you can see here, there's only one exporter currently. I could add a new exporter. I could say exporters, and I can say debug, and I can hit save. And it added that directly to my configuration. And then I can come back to my collector over here. And if I look, there should be an effective configuration. And you should see that in this collector configuration, it has added the debug exporter. So from the server, I have now managed a collector instance. Of course, I'm doing this locally, but this works over a network, I promise. I just didn't want to do it live over a network here. So very quickly and easily, I can kind of configure this. Again, the future of OpenTelemetry. So come back. So I covered a lot in a limited amount of time, 30 slides in 30 minutes. But as you can see, OpenTelemetry is more than just the 3 pillars of observability. Those are already very stable and maturing rapidly, and you can take advantage of them today, but they are not the only things available. Profiling, client instrumentation, OTTL, OpAmp, all of these cool new things are being added to the project, so the future of OpenTelemetry is very rich as well. With that, thank you very much. I have copies of the book, and I will take questions, I think, for 5 minutes, because we have about 5 minutes left. Thank you so much. Yes, and I'm going to need someone to help. He's going to help with the microphone. Or you can take mine to start while he turns it on.
So, as you mentioned, Elastic has donated the profiling, eBPF profiling. Similarly, they also donated the ECS semantic convention that they had.
Correct.
So what is the direction? Because today there are many companies who are heavily using for logs.
Yep.
But we see that semantic convention for distributed tracing is different.
Yep.
For metrics as Prometheus signals, whatever as labels, they are different.
Yep.
The naming convention in terms of dot versus underscore, that is different.
Yep. So your question is around kind of this convention in general. So Prometheus has not donated it to OTel, and so that will not be the standard for OTel. So like if we look at like the labeling for the semantic conventions you mentioned for logging, they will be based on what Elastic has today. Any vendor, any end user, anyone can come contribute to the project. There's a technical steering committee and governance committee that has to review all of this, and then the community will decide what is actually going to be accepted versus not. What I will say is that standard will change. Yes, Elastic donated it, but it will now become OTel compliant going forward. And the idea is Prometheus is natively supported by OTel. So I can receive in Prometheus format, it will convert into whatever semantic conventions OTel has, and then if I want to export that into Datadog format or Splunk format or New Relic format, all of that is possible too. So everyone's going to have different standards, but the fact that OTel has standardized means I now have an open standard that I can translate into and out of.
With Prometheus 3.0,
Yep.
it started to support dot annotation
That is
in
correct.
terms of the labels.
Yep.
So how you see the battle is going towards OpenTelemetry winning more, or
Well, I don't want to use the term winning. I think there's a lot of cool open source projects out there.
Yeah.
But I think you're seeing adoption across the board, whether it's end users, cloud providers, vendors, or other open source projects. I think this speaks to a couple things. One is there's a desire to have this, and I think end users are actually demanding it at the end of the day. We're trying to move away from being locked in and having proprietary solutions. We want to have a generic solution that works and future-proofs. OTel supports things like syslog, right? So like if there are other open standards out there, you should think of OpenTelemetry as a superset. The goal is it can support that and more.
in OpenTelemetry as a ecosystem or as a project, is there something looking for the compliance perspective, like many different compliance? Are there anything to be discussed in that area?
Security is being discussed. Unfortunately, observability doesn't do much in the security space today. I hope that that changes because with this data, you can actually do some cool things.
Yes.
And I know some vendors are, mine is, for example, but several vendors are kind of looking at how you tie security and observability together. I think that will be a future investment area, but there's not a lot of it in OTel today.
Yeah, you talk about in your book this part, but you very little part of it.
Very little, yes, and that's intentional because OTel doesn't have a lot of it. Yes.
Hi.
Yes.
I wanted to ask if anything has been done on the benchmarking side,
Oh, yes.
because if we are thinking of sending all traces, logs, and metrics all together through OTel collectors, and if I talk about scale, my system right now has 1 million data points per second.
Yep.
So how well it would perform in that at that scale?
Yep. Oh, I'm not on the internet. Oh, fail. Okay, so I only included one link, but yes, when I say the ongoing work, KTLO is like there's new frameworks, new instrumentation libraries that need to be supported, changes from a language perspective, like major versions coming out. Performance, scale, and reliability is another aspect here. I actually linked to a very cool blog post from Java talking about like some of the performance optimizations that have happened. And there's a lot of comparisons even between open source projects. They'll like compare themselves to OpenTelemetry and then perform like benchmarking stuff. I can say a lot of work goes into this in OTel. If you find a performance issue, you should absolutely file an issue. But in general, the community cares about this a lot. Vendors care about this, and users care about this. So if this didn't work, we wouldn't have customers using it in production. There's a large number of adopters. A lot of the scale issues have been figured out. Of course, any project still has work to do. So if you find something, let us know. But yes, this is a big focus, and I can tell you that this performs very, very well. Thank you. Yep. I don't know who has the microphone. Who's walking around?
Actually, we are using hundreds of collectors as of now.
Yep.
And OpenTelemetry is something which we are waiting from last 6 months or so now.
Yep.
So I know there are a lot of vendors who are releasing their fleet management, but we are just waiting for OpenTelemetry to be stable.
Yep.
Is there any way we can actually have an early adopter or something of that side? I mean,
For the op-amp stuff?
yes.
Yeah. So you can use the op-amp protocol today. I mean, it's in beta, so again, there could be some breaking changes. But if you want to use the server stuff, you either have to use what OTel has, I just showed you, it's kind of basic, or you need a vendor that would help you with that. There are several vendors that are working on it, but it's actively under development, I would say.
Okay,
Yeah,
because,
so I'm happy to like partner with you. I can tell you vendors that are working on this if you care, right? Because I'm very involved in the community. But early adopters, I mean, the best you could do is there's actually a SIG meeting, special interest group for op-amp. You could join those SIG meetings, and you can ask the community members as well that are contributing to this project.
Okay, and the second question is on performance itself.
Yep.
Currently, our collector goes up to 5 GB and even 4 core of resources. That's the size. That looks quite high to us.
Yeah.
Is there any best practices or guidelines which is
Always.
available to actually we can follow?
Yes, of course. Yeah, so there's performance optimization, there's best practices on how to configure it, like all of that exists today on the GitHub repo, so I can send you some information about it. If you're seeing a lot of usage, resource utilization, it's usually due to two things. Either the amount of data that you're sending, so the collector is scaled based on the signal data that you're ingesting, or you've configured a lot of complex processors.
Yes.
Going back to CRUD metadata operations, if you're using regex, it's not free, I guarantee.
I was coming to that. Actually, it's because of the processors. We know
Yes.
it.
Yep.
It's because of a lot of transform processor which is happening.
Yep.
And
So we should find ways to optimize that. So I mean, if you're having challenges with that, you could file a GitHub issue as well. But I'm happy to kind of chat with you kind of offline. We could figure out ways to optimize it. There are definitely ways to do this. And this is another reason why profiling can help. You can actually profile the collector, kind of cool. And you could figure out where it's spending its time and where you can optimize from that perspective too.
Sure, thank you.
Yes. Woo. They're going to kick me out in a few minutes, I think, but I'll go in the hallway when they
Hi,
do that.
just a clarification. Yeah.
Oh, hi.
Yeah. You mentioned something about correlation across
Tracing
logs and
metrics.
metrics in addition to tracing.
Yep.
So are we talking about having a horizontal correlation across metrics, logs and traces? Is that what you mean?
Yeah. So for example, you can add trace context to logs today in OpenTelemetry. So the trace ID, span ID information is added. Now I can go from a log to the associated trace or from a trace to the associated logs. That's what I mean.
This one.
Yeah.
One question.
Yes. Where's the microphone?
I have two questions. First is, what's going to be the future for hotel operator?
What's what? Sorry.
The hotel operator.
Operator? Oh, so OpenTelemetry can be deployed on Kubernetes, a variety of different formats. They have a Helm chart available today. You could clearly deploy it by yourself, or they have an operator. The operator is basically a CRD, custom resource definition. It can actually manage the collector. I don't see a lot of people doing that today. I see a lot of people deploying the Helm chart to manage the collector. The operator, they're primarily using to inject instrumentation at runtime. So my recommendation would be to use the operator for that second use case. I wouldn't necessarily use it to manage the collector. There's more work going on from an operator perspective, so there's a SIG for that as well if you want to kind of get involved and learn more. But in my experience, most people are using the Helm chart.
Yeah, thank you. One more question. So we have different exporters, and these are not 100% what, let's say, a Prometheus exporter we use. It's not 100% what OpenTelemetry can give. So what's the future on that as well?
For Prometheus? So Prometheus should now be
No,
fine.
not just Prometheus. So there are other exporters. So in our environment, we are using GCP exporter.
Yep.
So we don't get everything out of it.
Yeah. So you should see who is maintaining the exporter. So if you go to the contrib repository and you click on an exporter, everything has a code owner. You can reach out to those people directly. Usually if it's a vendor, you said GCP, I would reach out to GCP and say, hey, your exporter's not working well, right? So the problem usually is that they are not translating from OTLP into their format properly. There could be a reason for that, could be a limitation on the back-end side, but I would reach out to the vendor and say, you need to fix your exporter.
Hey, Steve. Thank you for the great talk. Something that we are looking into is CI/CD observability and something OpenTelemetry just announced.
Yep.
What are the new developments on that front?
Yep.
Because I feel like the DSL, the OTel language that you just displayed, I think that would be critical for standardizing a very chaotic use case. So yeah.
Yeah, so CI/CD was actually announced at KubeCon North America. There was actually a CNCF blog post, which is pretty cool.
Indeed.
They're doing it from a semantic convention perspective. I actually have the link that was on the ongoing work slide. FYI, I'm going to upload these links, this stuff to the schedule, so you'll be able to see the PDF and all the links as well. But they're going to add semantic conventions. It's still kind of early days. They've been working on it for the last 2 years, to be fair, but they're not stable yet. So there is another special interest group that's happening for CI/CD. So if you want to attend that and kind of get the update, you can. But I think, yes, there is a strong desire to get there, because if your code's not working in production, it's likely because of your deployments. You need the CI/CD visibility.
And especially the visibility will really help
100%.
overall.
100%.
Yeah. Thank you.
Yep, thanks.
Yeah.
Okay, we gotta go, folks. So I'll meet you guys in the hallway.
Okay.